Hello everyone, welcome once again to another session of pre-calculus. Today we will talk about modeling. Now we can use mathematical expressions to model or to approximate phenomena in the real world. Most often we use linear functions. Sometimes we try other function forms which we'll look at later on, but for today we will only use linear functions. So there are certain steps that we must take when we are thinking about making linear models of real-world phenomena. First of all, we must read the problem. Then we can try to draw a picture if possible. Then identify the variables. Next, we make a plan of how are we going to solve this problem, and then execute the plan to get a result. Finally, we will check our work. Now, there are many real-world phenomena that we can use linear functions to model. For example, if you are working and earning an income or salary based on the time that you put in, so income or salary, so your income would be as a function of time, where the variables would be income as your dependent variable and time as your independent variable. If you were producing some stuff or making stuff and making a revenue or selling based on the amount that you produce, then you could have revenue as a function of quantity or amount of things that you make. Okay, so these are possible things that we can use linear models. There are many other things in this world, for example, expenses and so on, that we can use linear models for. So let's check out a few examples. This example says a monthly cell phone plan has a base cost of $100 plus 10 cents for each minute. We're asked to write a linear model, a linear function to model the monthly costs C of t in dollars of the plan. Now, first of all, we have our cell phone. That's right. And it has a plan. It has some fixed cost or base cost of $100. Then you have some variable cost or some flexible cost of 10 cents per minute, right? 10 cents per minute, okay? We are going to use this to find the total monthly cost, and that's what our model for the monthly cost. So our variables then, in this case, like we used X and Y, our variables would be our cost or C of t, right? And time, which is t, okay? So cost is our dependent variable, right? So our dependent variable is cost, and your independent variable is time. Your independent variable is time. So what we want to do, we want to relate C of t to t based on the numbers that we are given, 100 and 0.1 per minute. Okay, so let us write it out. C of t is equal to some number, which is 100, plus 0.1 times t. So for every minute, every time unit t, we are spending 0.1 of a dollar or 10 cents per minute. Okay, so we have done then with part A. That is our result, okay? And let's look back at what it says. It says the base plan is 100. It has a flexible cost of 0.1 per minute. Our minutes is our time variable, t, right? And C of t is our cost. Let's look at what part B is asking. It says evaluate C of 2000, and interpret the meaning in the context of this problem. Now, C of 2000, what does 2000 mean? 2000 means that our time that we spend, so T is equal to 2000 minutes. That's what it means, okay? We are going to plug this 2000 minutes in wherever we see T in our equation. So that'd be 100 plus 0.1, and we see a T there. We will times this 2000, which is the time that we spend. So we plug in the 2000 for T. Now this C of 2000 does not mean that we multiply C by 2000. But this 0.1 parentheses 2000 means that we multiply. So we're not doing any multiplication on the left side. We only do it on the right side. So C of 2000 be equal to 100 plus 0.1 times 2000. That gives us 200. So our answer is 300. So C of 2000 equals 300. Now what does this mean? The meaning is that our cost based on this multi-plan is $300. So the cost is $300. Cost is $300 when we talk 2,000 minutes, pardon, 2,000 minutes using this plan. We talk 2,000 minutes using this plan, right? And so that is what the meaning of the problem in this context is, given our 2,000 minutes usage, right? So C of 2,000 means the cost when we have spoken 2,000 minutes in the month based on that monthly plan. Okay, let's look at another example. Another example says X represents the years since the year 2000, and Y represents the average consumer spending. So X will be years since 2000, the year 2000 that is, and Y is average consumer spending. So we're just catching a little graph right here that says X and Y. We're going to put in some points. Let's say this is 1 year since 2000, which would be 2001, 2 years, 3 years, 4 years, 5 years, 6 years, and so on. And let us make the scale on our y-axis to be in hundreds. So make that 100, 200, 300, 400, 500, right? Now we are given 2 points, 2 and 300. So let's plot those in at for part A, 2 and 300. So that's 2 on the X, 300 on the Y, and then we're given the other point, 6 and 400. 6 and 400, we plot those in, 6, 400, we plot those in, and then we want to make a linear model. We want to make a linear model. We want to write a linear equation. That's what we're doing. We're trying to write a linear equation to represent this situation. So we put in our 2 points, draw a line through it, and what we want to do is, from this situation, given the 2 points, 2, 300, and 6, 400, how can we write that equation? Let us try to write that equation in slope-intercept form. So y is equal to mx plus b. Now for y is equal to mx plus b, we want to find a slope and an intercept. The slope is m, and m is given by the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we need then to identify an x sub 1, a y sub 1, an x sub 2, and a y sub 2. We have chosen 2 for x sub 1, 300 for a y sub 1, 6 for our x sub 2, 400 for a y sub 2. When we plug these in, y sub 2 minus y sub 1, that'd be 400 minus 300. And x sub 2 minus x sub 1, that would be 6 minus 4. So we continue working that out. We have 400 minus 300, that's 100, over 2, that is, over 4, over 4. So that's going to be equal to 25, right? So m equals 25, and we want to find our b. How do we find b? Now, in order to find b, we got to choose a y and an x from any of these 2 pairs of coordinates. So we could choose an x equals 2 and a y equals 300. We know that m is equal to 25. So let us plug that into y is equal to mx plus b. So plugging that into y is equal to mx plus b, we have 300 is equal to 25 times 2 plus b, and 300 is equal to 25 times 2 plus b, so 300 is equal to 50 plus b, because 25 times 2 is 50, and so if we subtract 50 from both sides of the equation, doing a bit of algebra here, we have 250 is equal to b. So we have found our slope, we've just 25, we've found our intercept, which is 250. So our equation then would be y equals 25x plus 250. Okay, y is equal to 25x plus 250, and that is our linear equation that we have used to model this situation. Now, the next part B, asks us to interpret the meaning of slope in this context. So the meaning of slope, m is equal to 25. What does that mean? It means that in this context, that each year the change in the spending is 25. Okay, so each year the consumer spending increases by 25, or the average consumer spending increases by 25. Increases by $25. Increases $25. Okay, what about the intercept? The intercept is 250. So the y-intercept is b equals 250. Means that in the year 2000, the spending, or the average spending, was $250. In part D, we're asked to find the spending in the year 2007. So y is equal to mx plus b. So y would be equal to then 25 times 7. This is the year 2007 plus 250. And when we work that out, we should get 425. So that's the average spending in 2007 is $425. Thank you. Please like and subscribe.